I'm Ennemcien. Today, let us begin with study of vibrations. Vibration is a commonplace motion, type of motion. We can pass even an hour without experiencing, without feeling, without enjoying, without producing vibrations. Music is a product of vibration. Everywhere you look, there is one or other type of vibration. So let us begin our theory from a simple example. This is a helical spring and this is a load of mass m. At O, this block is at rest. Now there is static equilibrium between weight of the block mg and the restoring force developed in the spring. These two forces cancel each other and the system remains at static equilibrium. Now suppose you pull the block down by a distance x so that the center of mass of the block occupies the position O1. Now the spring is elongated, extension x is downward, and now the newly developed restoring force in the spring Fr is upward. We have seen that this restoring force Fr equals minus kx, where k is the spring constant or spring factor or stiffness, etc. As we pull the block down and down, or as x increases, Fr also increases. So at a certain position, the block finds it difficult to move further downward. So it goes up under the influence of the restoring force. It should stop at its previous resting position at this level. No, it won't stop there. It will go up further under its own inspiration. How does it happen? What we expect is, when we release this block, it will move up to the previous equilibrium position and remain there with ease of mind. No, that is not what happens. It goes further up without stopping at the mean position or resting position. This is due to inertia of the block. So due to inertia, the block moves further up through a definite distance x, compressing the spring. So the restoring force now develops, which is downward. So it pushes the block again into the downward direction, and the block comes back to the original position or resting position, but it won't stop there. Due to inertia, it will move down further, and the process will go on indefinitely. If there is no air friction and other dissipative factors, it will go on moving up and down. This kind of motion is simple form of vibration. We call it as simple harmonic motion. So simple harmonic motion to take place, the essential conditions are two. One, there must be a restoring force. It must be a linear one. Linear one means that restoring force must be proportional to first power of displacement, that is F equals minus kx. The second requirement is the presence of inertia. The oscillating body should possess an inertia factor. Here, in straight line vibration, mass provides the sufficient inertia factor. So, it will move up and down with a definite period of time, a constant period of time, which depends upon property of the spring and the property of the suspended block. Now, we have seen earlier that Fr equals minus Kx. Fr is rate of change of m into a, mass into acceleration. Acceleration is dv by dt, rate of change of velocity equals minus Kx. Or that is m into d by dt of v is the rate of change of position dx by dt equals minus Kx. d by dt of dx by dt means we should differentiate x 2 times or twice, which we put using the symbol d square x by dt square. So, m into d square x by dt square equals minus Kx, or d square x by dt square equals minus k by m into x. We put k by m as omega square, a new constant. So, what we get? D square x by dt square equals minus omega square x. This is the differential equation of simple harmonic motion. Acceleration equals minus a constant into displacement. That displacement is measured from the resting position or mean position of the motion. After all the vibrations, it will come to rest, ultimately, finally, to this resting position. So, x must be measured from this resting position. And the differential equation is d square x by dt square, or acceleration equals minus omega square x. Here, omega square equals k by m. That means omega is square root of k by m. This omega, it can be shown that is omega is equal to 2 pi divided by periodic time of vibration t, capital T, that is equal to square root of k by m, from which t equals 2 pi root of m by k, or period t equals square root of m is called the inertia factor and k is called restoring factor. So, general expression for time period of oscillation, simple harmonic motion, is t equals 2 pi root of inertia factor by restoring factor k. This is the different time period is the time interval required to complete one vibration, one up and down motion. If it is horizontal, one to and fro motion, that is one vibration. So, number of vibrations in 1 second is called frequency, and time required to complete one vibration is called time period. And the formula for time period is t equals 2 pi root of inertia factor by restoring factor. Thank you.